Now I would like to go and introduce you to the first speaker, Marc Krellenstein, who's the founder of Lucid Imagination. Marc is one of the early designers and developers of enterprise search. As a co-founder of Northern Light, which was pre-even Google, he's involved in the enterprise search market for quite some time and identified that Lucene and Solr software became as good or better than any commercial offering out there. So I'm very proud and very happy that he is going to talk to us today about the past of the enterprise search and the future enterprise search with the open source. Marc?
Good morning. So I really just have one slide that's going to talk much about the past. I think it's sort of interesting, some of the points here. Full-text search, we actually owe the US government thanks for the creation of full-text search. People don't realize that. It's not their research arm that started it, but the antitrust division that we can really thank for full-text search. Back in 1969, the US government sued IBM for antitrust violations. IBM had a mound of paper that they wanted to go through to prepare their defense, and they figured it was too much paper to read. So they created something called STAIRS. I think it's Storage, Technology, and Information Retrieval System. Really the first commercial full-text search system. The US government, not to be outdone, hired Battelle Labs in Ohio to build a system so that they could search all the documents they wanted to use to prosecute IBM. And those are really the two first sort of granddaddy search systems. As recently as about 10 years ago, IBM was still selling STAIRS. I ran into it every now and then. It's not much in use today anymore. From the same era, we have other products. BRS, really a derivative of STAIRS. Bibliographic Retrieval System was used to search scientific data, library data. Dialog, again, one of the early big database-oriented search systems that search different kinds of proprietary content, bibliographic data, published data. Verity, also an early player, especially in the government space. The challenge for these products, we sometimes forget because search is online now and is everywhere. The challenge was if you have a lot of paper and you have too much to read through to find something, what do? The challenge was recall, as we say. How do I find the thing that I want? How do I find it in all this content? The challenge was also scalability, meaning there was a lot of it. By definition, there was a lot, or you would have done it by paper in the first place. So scalability is interesting. At every point in time as I go through this slide, scalability is an issue, but of course what we mean by scalability has changed a lot from a few 100,000 documents being too much to search to many billion documents maybe being too much to search. The scalability challenge has grown with the technology. If we fast forward then to internet time, Lycos was one of the first internet search engines, and again the challenge was really recall and scalability. There's this thing now called the internet. It's got a lot of information. How do I locate something on it? How do I start to really exploit it and make some good use of it? Fast, one of the very first commercial search engines, developed capabilities to find files, actually MP3 music, if you go back that far. This was in the 90s, pre-Napster and those kinds of things. Different kinds of files, and it was hosted on Lycos as sort of an augment to the Lycos internet search capability. Had no concept then, nor did really these other products all that much in the beginning, of relevancy, of precision, which we'll talk more about in a second. The challenge was, how do I just find something? I'm not going to worry about much else. If I can find it, I'm already happy. Fast forwarding from there, InfoSeek and Excite, other internet search engines that grew the size of the index above Lycos. AltaVista was a big breakthrough in scalability. That was the first really big internet search engine, for those of you who go back that far. It was exciting to type in heart attack and find 100,000 documents. After a little while, 100,000 documents didn't seem like such a great thing when you typed a query, but we'll come to that in a second. Another trend here that I want to talk about, which really spans forward all the years, is the concept of centralized search and distributed search. So all of those products initially were centralized search systems. They solved the scalability and recall problem by building a single index. An index is what makes full-text search faster than searching through paper, right? It's the index, like the back of the book index of all the words in all your documents or all your product descriptions or all your tweets or whatever you're indexing and searching. And those products had a centralized index, which limited the scalability in some ways. At the time, it sort of just about managed okay. AltaVista was basically a centralized system, and it stretched the limits of it. But people could see that a centralized index, putting an index on a single machine with the single machine limitations of memory and disk space, were going to create some limits as scalability grew. So pretty early on, people had the idea to distribute the index, right? To split the index across multiple machines, any number of machines, which basically, once you make that one important transition, you suddenly have unlimited scalability. You can combine the search results from an index split across 1,000, 100,000 machines, if you're Google, for instance, and merge the results, and you have tremendous scale now. At some point, perhaps the time spent fanning out the search and merging it, the network problems can be an issue, but we're a ways from that. And then you could do a two-level distributed and so on. So it's interesting that in the early days, they were all centralized, but FAST, really one of the first ones from the beginning, had a distributed architecture, as did Google, and as did Lucene and Solr, which actually all started around the late 90s. And those three products, from that point of view, are the modern architecture for search today. And only those three products, I would say, really had that architecture from the ground up. So it already puts them in a separate class in terms of scalability and capability. So the next challenge, as I said, AltaVista was sort of the culmination of the recall excitement. Wow, all this stuff, but people realized that it wasn't so great to get so much information back. They'd like to find just what they wanted. Not just get it back, but not get back a lot of additional stuff that made it hard to see the good stuff. SMART was a research effort that provided tools for relevancy ranking, for precision, that were used then by a lot of these modern search technologies. FAST later on, after it added relevancy ranking. Google from the start, Lucene from the very start. Really one of the engines that had best practice relevancy designed in it from the beginning. Authority scores, again, moving forward now in time, really became another innovation. SMART had innovations like not all query terms are created equal. The rarer terms count for more. You don't just want to count the query terms in the document to see what's the best document. The terms that are rarer, that have more information content, count more as you're ranking documents. One of the next big innovations was really Google's. Other people had the idea, but Google exploited it brilliantly. And that's the idea that the authority of the document, independent of how the query matches the document, might tell you what's a good document. And for Google, the authority of the document was the number of links coming into that document. That was really the innovation that made Google so good, not just matching the query to the documents as best it could, but independently ordering those documents by how popular they were, which was a pretty good stand-in on the internet for how good they were. Browsing and clustering and faceting are sort of another dimension of relevancy ranking. You could argue they're not really relevancy ranking. In some ways, they serve sort of two purposes. One is sometimes you don't really know what you're looking for. I mean, Yahoo early on had a browse-only model where you could sort of go through categories to find what you were looking for, and that works in certain situations. Clustering and faceting work nicely when what you're looking for is not specific enough. It's sort of the analog I like to talk about. If you go into a library and you say, I want to know about baseball, they don't drop 8,000 books on your feet. They would ask you a question, right? You need to refine the query. There's not enough information very often. So browsing, clustering, and faceting lets you sort of have that dialogue with the system. You type in a query, you get back a bunch of categories. Oh, now you can specify your query more completely than you probably bothered to at the beginning. So they're another way to get to the good stuff, not so much by ordering the documents better, but by providing an additional tool to navigate to the documents of interest. And they've been there from the beginning. In the case of browsing, clustering came later. Faceting, really that exhaustive list that you see on the side of Amazon when you type in television, which is too general to find the best television, but you see the manufacturers and the size and the type. That's really been exploited a lot, especially in the e-commerce environment. So precision became sort of the next big challenge after AltaVista. Autonomy was an early enterprise search system that did a good job of precision. It was sort of a corporate intranet search engine in a box. Worked pretty well out of the box using some of these technologies, also using its own particular cut at relevancy ranking, sort of a non-standard approach that Autonomy uses by itself. Google, of course, and I'll talk more about that in a second. The authority scores were a big breakthrough in precision of internet searching. Lucene and Solr had best practice relevancy ranking from the beginning. It's really the only product, only technology in this list that has relevancy ranking as its default search capability. It's built that way from the ground up. The next challenge I would say, and these are less challenges in some ways than they are new standards, we'd have to say, that were established by Google and became challenges for everybody else to copy. Recall and scalability, narrowing what you found to just what you want, and doing it fast. Google really made that possible, really changed people's expectations of what search should be. Before that, search could take seconds, minutes sometimes in the early search products. Google gave great results and gave them sub-second. And that became, if not the new challenge for everybody, it became the new standard that other products had to meet. Google also championed simplicity, right? Google search box became the concept of what people want from search. I just want Google for this data, for my data. And again, became an important challenge going forward that other products tried to meet. Fast did a good job on the performance side. Lucene and Solr were high performing from the beginning and have gotten even faster over the years. Being simple, as Google really championed, is still a hard task for a lot of these technologies. Lucene and Solr are simpler than fast, simpler technologies to use, less complex to maintain. Google, sort of mixing the use of easy here, Google is simple to use for a user. It's actually somewhat complex to administer. And then I would say the last challenge, and now coming sort of all the way forward, so search has achieved a lot. If you look at those first categories, if we look at up through simplicity, Google is pretty good. People say Google finds your answer 2/3 of the time. Depending on your point of view, that may not seem great, but if you've been around search for 20 years, 60% is fantastic. 60% answer rate is really great. And it does it fast, and it does it simple. What I would say the last challenge now, and we can thank Google in a sense for this challenge, Google has shown that search is valuable everywhere. Right? Search is almost the new universal interface. It's easier to search than to browse. It's easier to search than actually type a long natural language question. We'd like to put search in lots of places. And one difficulty with all of those technologies, which a lot of them, if not most of them, have achieved those first categories, is that they're still expensive, they're still difficult to use, and they're not very flexible, partly because they're not open source. Right? They all come with their own limitations, their own subset of API capabilities, their own out-of-the-box tools that you can maybe customize, maybe can't. The point where we're at now, I like to think, is that with Lucene Solr, we've achieved those things with other technologies too. Search has in some ways become commoditized. All the search products can do a pretty good job of recall. Most of them do a decent job of precision. Most of them are fast. Simplicity sort of depends. But only Lucene now really lets you take advantage of that, and Solr, and deploy search in all the different situations that you might want to, because you can tailor it the way you want to, because it's affordable, and you can put it in all those different places. So let me just talk a little bit about Google. I've said some of this already. You can't have a search presentation without talking about Google, I think. Google was really the breakthrough in the precision of internet search. Again, it exploited that popularity factor. That was a brilliant thing to do for the internet, right? It proved the importance, in fact, of tailoring your algorithm to the particular data and to the particular users that you have. For the internet, popularity is a great tool. It's more than enough good answers. The problem is, how do I get rid of all the bad answers? That's what made Google better than Alta Vista. Instead of a few good results and 7 results that were, some of which were porn and some of which were spam and some of which were log statistics, they weren't there anymore because none of those were the most popular pages. It didn't matter if it wasn't the best document, because there's more than enough good stuff on the internet. It just had to get rid of the bad stuff. So by understanding the task of internet search, Google did a really great job. And as I said, it set a new standard for search performance, set a lot of new standards. It really proved the value of adaptive spell checking. Google was really the first time in force that spell checking didn't simply work off some big dictionary. Previous to that, spell checking was done by comparing query terms to a dictionary. Well, that's fine, but it doesn't do very much for Marc Krellenstein, if that's your query search. I'm not in any of the dictionaries so far. It doesn't do a very good job for product names. It doesn't do a very good job for the misspellings or the variants of spellings. Google looked to do its spell checking against the terms that were actually in the documents, and used frequency information to figure out if you typed in this word, whether it's in an English dictionary or a French dictionary or not, if it occurred 4 times, but flipping one letter made it occur 4,000 times, you probably meant the other spelling. So, and Google really championed that. And that's now the new standard, of course, for spell checking. Google demonstrated the power of distributed search. Those other products up to that time mostly didn't need it. At the Google scale, at billions of documents, that centralized search model that sufficed in the beginning of search didn't work anymore. Google's architecture had distributed search, and Google was the proof point for distributed search. Google's 8 billion or 12 billion or whatever the number is now index runs on hundreds of thousands of machines. As I said, it reinforced the importance of simplicity and a single search box, and it did all the proselytizing for search that a search person could hope for. Again, just to emphasize the point, why Google is not the answer for all search going forward, why Lucene and Solr in some ways are better, Google is an application. It's a technology too, but we don't get the technology when you license the Google search appliance, really. And when you do the internet search, you're really just using an application of Google's technology, very well tailored to average consumers searching the internet and internet data. Again, most of the data there is bad. There's more than enough good answers. You just want to screen out the bad stuff. Some other interesting aspects that Google understands. There are no security issues. Google doesn't bother about that, doesn't have to put any effort into that. There are privacy issues that limit how much Google can exploit from searches to inform another search. If you're a Pfizer and you've got a new idea for a compound for a particular disease and you type that in, you don't really want Google to provide that result to some other pharmaceutical company typing in the same disease. I mean, it would be a help to that person to use the information that this other pharmaceutical researcher did, but there are privacy issues in Google. If I jump to enterprise search, those privacy issues are gone. Right? Within an enterprise, if I'm a searcher at Pfizer and I do a search, and there's another searcher down the block or down the hall from me, and they do the same search, it's great if my search can benefit that person. Right? There's no privacy within the employees. It's sort of the flip. On the other hand, there are security issues. Certain documents may be off limits. In terms of speed also, Google showed how speed was important. Consumers are impatient as a rule. In the enterprise, it's kind of mixed. Speed is important for a lot of people, but in certain situations, speed may not be so important. The best enterprise search tool will be like Google in that it will be an application of underlying search technology to a particular set of data and a particular set of users, which may not resemble Google at all. Okay, just a quick sort of techie slide on recall and precision. How many people know the technical definition of recall and precision? Maybe I can skip this. Less than half. So let me do it quickly because I think it's good for appreciating what comes on in the rest of the conference. So recall, I sort of talked about it loosely before. That's the percent of the documents that are in there that meet your answer that you get back. There's 50 good answers for your search and you get 25 back. Not bad, you got a 50% recall. If you got all 50 back, you'd have 100% recall. If you got none of those 50 back and only other things, you'd have 0 recall. That wouldn't be so good. Precision is different. Precision looks at what actually came back and says, how accurate is that list? In other words, the good documents on it, how do they compare to all the other bad documents on the list? What's the percent of all the documents that were returned that are actually good? So if I do that same search, there are 50 good answers, and I get 25 back, I have 50% recall. But if I also returned additional bad documents, my precision drops. If I return 100 and I only get the 25 good ones, I only have 25% precision, right? I've got only 1 out of every 4 documents are actually good. So precision is the percent of what came back that's good. Recall is the percent of what's really in the system that would be interesting for my search that comes back. The ideal, of course, is 100% of both. Get just what I want back and nothing else. 100% recall is easy. You just return the whole database. Right? All the good answers that are in there are, by definition, in your result list somewhere. But the precision would be so low that it's a useless strategy. It does sort of indicate, in fact, that the recall problem is a little easier. That was the first problem, and it's easier to solve. The harder problem is you can improve recall by, in a sense, bringing everything back, but how do you screen out what really isn't relevant? That's the harder problem, and that's sort of an unending problem from a lot of people's point of view. The bottom line is, again, that you need adequate recall and adequate precision for the task at hand. That's going to depend on the data. It's going to depend on the users. We had a government customer who had searches that were thousands of terms long. They were passed down from generation to generation, and they had wildcards, and they took a very long time to execute, 45 minutes. And we went in to talk about Lucene Solr and said, we can make those searches a lot faster. said, well, the recall is really important. We don't care about the speed so much. I said, 45 minutes? Well, we come in, we start a search, we go get a cup of coffee. We talk to somebody else. We come back and the search is done, and that's how we work. I said, okay, well, but you get back a lot of stuff. I mean, the good stuff is on top. He goes, no, not really. I said, the good stuff isn't really on top. Well, you get back so many results. How do you handle that? Well, we have a lot of people. We can't miss anything. We're most concerned about recall. Better precision would be better, but we really can't miss anything. So it depends on the task. That's not typical, but you can imagine certain government agencies for whom that's important. I'm not going to spend much on the next two slides, just to show again that this has been kind of commoditized. Search technologies understand pretty well how to do good recall, especially. Precision is a harder problem and kind of never ending. The key points here are have the data that you want to search. If you don't have it in the system, you can't find it. It's an obvious thing, but a lot of search systems fail because the data that really meets the needs of the queries of the users actually using the system was never loaded in the first place, or parts of it were missing, or it was corrupt, or a million other things. Normalizing the data. The data is very precise. A word is very precise in a document, and the query usually isn't interested in that level of precision. Two words that differ only because one is plural and one is singular both meet the needs of the searcher, or if an accent mark is left out or not left out. So you need to normalize the data to the level of the information content need of the user. They don't care, usually, whether it's the accented form or not. Of course, in another application, you might not want to normalize that. You might care that something is spelled with a capital letter or not. So again, it depends on the application, but normally, the typical case, you would normalize the data. Spell checking, we can see, improves recall greatly. If you misspell the word, the system doesn't tell you and you don't find anything, it's not because there are no answers there. Synonyms are vitally important. Synonyms are only recently well understood, but they make a big difference in search. It's one of the reasons search is, frankly, probably mediocre somewhere. You can't count on the words that someone's going to use to find something. You search on Notebook, but you don't get back any laptop pages. That's a synonym problem. And then natural language processing, and we could have a whole separate discussion about how that improves recall and precision too. Keyword searching, which all of these technologies are sort of based on, and people have become adept at using well, has its limits, right? If you've got a search that's more abstract, that's more inferential, there's more context. If I look for recent documents on Asia, searching on the word recent is not going to be a winning strategy, probably. What I really would like to know is that recent documents implies something about the date attribute of the documents, and I'd like that translation. It's a certain kind of comprehension. And some of that exists now, and more of that is coming. Good precision, again, I'm not going to talk about these. Some of those early ones have come out of the research literature, have been around for a while, have been refined, looking at the query terms in different ways, looking at the words near each other, looking at where the words are. So if your query term is in the title, it's probably a better indicator of a good document than if it's in the middle of the text somewhere. I want to talk just about the last few because they're interesting and again, sort of take us more into the future and work that's going on right now. Authority, I mentioned. Relevance feedback is another interesting one. One of the big problems with search is that queries are too short. Users, want you to read their mind, and changing user behavior is really hard. They will probably always be too short. Even if they've gone up in length, and the average query has, by some measures, gone up in length, by other measures, that's not as clear, there's usually not enough information to do a really good job. Search systems work really well on long queries, if they're tuned right. So one thing you can do, since the user's not going to meet you halfway, users don't like to meet you anyway, is to expand the search in some way, get more terms. And one way to do that is have the user go through the document and say, this was a good one, this was a good one. Now the system can look at the words in those documents, see what words are common to the good ones, maybe downplay the words in the documents that the user said weren't good matches, and create a new search that has additional terms likely of interest that the user didn't have the patience to give you in the first place. The catch with that, and many systems have tried this, is that users don't do it. They don't want to rank the documents. And they want to do a search. If the results aren't good, they want to do another search, maybe another try, and then they're gone to another search engine. Implicit feedback is a tool that you can use to automatically derive those terms by assuming the first few documents are good. If you've got a good search system, probably the first few results, 2 or 3 of them will be good, and getting the words from those as if the user had said those were good documents, and now expanding the search. Actually a proven technique that works well in the research literature. All the contestants in the government-sponsored text retrieval competition use implicit feedback, almost a guaranteed improver. Why isn't it there out there in internet search? Why isn't there in enterprise search systems? One reason is, why doesn't Google use it? Implicit feedback means you take the search, you get some words to enlarge a search, and you do the search again. You've just doubled your search volume. Now, Google is really big, but it's not really interested in doubling its search volume automatically, especially when it's already the precision leader in Google. And that's expensive. Why don't enterprise products use it? I have no idea. I've never been able to figure out why this sort of proven improver of relevancy isn't used, but it's something you can do with Lucene and Solr. It's something that Lucid Imagination has worked on, and again, shows you the flexibility of the technology to use it appropriately in the right situation. The last point, I talked about clustering already, is an interesting one. There's a trend now in search and in other areas to sort of, in some ways, go away from these complicated algorithms and just mine data statistically to do a task. Google Translate is maybe the best example of this. Google Translate, which translates web pages into arbitrary languages, doesn't use any of the fancy machine language translation technology that came out of Carnegie Mellon or any of these places, and outperforms them. And the way it does it, it's sort of crude, you would think, from an algorithmic point of view. It just stores huge volumes of previously translated texts that were translated by hand. And then when you type something in that you want translated, it looks it up and see if anybody else ever translated it before. And if it finds 1,000 translations of that, it kind of figures out what the best, most likely translation of it is. So no algorithms, no natural language comprehension, a pure statistical approach on a huge amount of data. That's the catch. You have to have enough data for that to work, and it works really well. IBM's Watson product, people have probably seen that, it plays Jeopardy, doesn't really do serious natural language processing, doesn't really do serious search in some ways. It's a statistical approach against a huge amount of data that they fed into that system. So we may see more along these lines in terms of future efforts on precision and recall. Okay. So Lucene and Solr, so let's talk about those, which is really the point of this conference. I've touched on some of these points already, and this is just by way of introduction for some of you. Some of you, of course, know this and more about this better than I do. Lucene was built in the late 90s by Doug Cutting. Doug was great. It was the third search engine he built. He did a really good job. He wrote it in Java because he wanted to teach himself Java, so we're the lucky beneficiaries of that. It's got state-of-the-art technology. Was state-of-the-art then is still state-of-the-art in terms of making indexes compressed and working really well. Relevancy was built in from the ground up, all the best practice features, very flexibly. It was contributed to open source because Doug was tired of writing software and going to another company and having no access to it. It wasn't so much a free speech kind of thing or a commercial property is bad kind of thing. It was a practical effort to get development in such a way that he could benefit from it later, and also to get other people to continue the development. By 2005, Lucene wasn't very widely known in the enterprise world, in the Fortune 2000, but a lot of technology companies knew about it because it was so good and it was free. And that's sort of the bottom line here, right, about Lucene and Solr. You have technology that's as good or better than any other technology, and it's free. That's a pretty compelling combination. So by 2005, it was used by a lot of technology organizations to power their search websites, and so on. Solr came about in 2005, thanks to Yannick Seely and CNET. The story I like to tell about Solr, which is mostly true, and Yannick can correct me where I sort of elaborate too much, maybe, is that CNET made Yannick contribute it back to open source before they would use it. So think about that for a second. A lot of companies are afraid to use open source. A lot of companies think everything they do should be proprietary. Not only did CNET want this to be open source, they didn't want to use it until it was open source. And that's because CNET knew they weren't a search company. They knew they couldn't maintain the best quality search engine going forward. They wanted other people to do that, who were passionate about it and who knew how to do it, and who would be in large numbers to be able to do it aggressively, which CNET couldn't afford to do, didn't have the know-how to do. It was really, again, sort of a continuation, I think, of Doug's idea, open source as a development approach to capabilities that can be developed by the people most passionate about them in a free and open way, in large numbers, and then other organizations for whom that technology is a one-off get to benefit. Today, we know Lucene and Solr are used very widely. A few companies you've probably heard of there. Not much more to say about that, I think. Current Lucene Solr strengths. Again, I think the winning proposition here, historically, why Lucene Solr is so important now, why it may be dominant for some period of time, as long as it continues to innovate, is that it's so strong and it's open source. I mean, that's the combination that's a killer. So it's got the best practice index architecture that I talked about, really, I think, alone with Google and Fast. It lets you go to billions of documents. MySpace has 6 billion documents in its Lucene index. We've heard even larger numbers in other Lucene indexes. It's got really good ranking, and it's flexible, and it's extensible, and since it's open source, it's completely customizable at the end of the day. It's got great query performance. Lucene's query performance was very good from the start. I don't know that it was the best. It was a Java program. Nobody necessarily expected it to be the highest performer because of the work that a lot of the great committers have done on indexing side, on the query side, Mike McCandless, if he's here, at IBM, and other people, because of improvements in Java. Lucene is, by our benchmark today, the best performing query search technology. Pretty amazing capability for a Java-based, originally Java-based, open source technology. Outperforms the competition on query throughput in our benchmarks and customer benchmarks and average query speed. It's full-featured. It's got all sorts of capabilities that you expect from a modern, advanced, and continuing to expand and develop search engine. The innovation is rapid in the open source. The architecture, of course, is extensible and controllable because it's open source. There are, by the way, no license fees, which is nice. And again, that bottom line, which I think is so important. There are weaknesses to Lucene and Solr that it's worth pointing out, at least to corporations that may be considering it, that are sort of further down the curve in their adoption of open source. A lot of those are the flip side of some of the benefits of open source. So there is no organization, or there has been no organization up until maybe recently, that provided regular commercial support for Lucene and Solr. It was open source. That was the idea. Because it was open source, there was no organization also where you could just go and count on getting training or consulting or systems integration or something like that. The QA of Lucene and Solr is very good, actually. I mean, unit testing is sort of a religion in the development of Lucene and Solr. Integrated testing, not so much, maybe. When people want to do integrated testing, that's certainly done before Lucene and Solr releases, but there's also the model of, well, let's release it and find out what other problems there are in it. That's a logical model, given the pace of development and the way people then deal with fixing the bugs after an initial release. It's not always the expectation of a company that wants to pick up a release and put it into production soon. They'd like to know that it maybe was already tested. For some people, not for a lot of the people probably in this room, but for some organizations, open source is still a little scary. You go to the Lucene website or the Lucene Solr website and you're not quite sure which version to download. Do you want last night's build? Do you want trunk, whatever that means? Do you want the last release? Is the release before that more stable? What's going on tomorrow? There's a patch. What the heck? Do I need those patches? Where's my menus for setting up an index? Again, there's a range of users here, and that hasn't slowed down the adoption of Lucene, but it may be a weakness, and it may be a slowing factor in the wide-scale adoption of Lucene and Solr as really the dominant search technology, which again, the combination of capability and price, I think, means it could be. There's some other weaknesses, and different open source projects have different sets of weaknesses. So Lucene Solr development has, for whatever reason, the function of the people involved, tended to focus on core capabilities. So and part of this is the Apache model. It's a pure, implementation, and there are no dependencies. There are no third-party technologies built in. You often need those. I mean, especially search has got, because it's a fuzzy problem, you usually apply lots of different technologies, so those aren't there in Lucene Solr to start. A lot of effort has gone to Lucene Solr, especially in the last years, on performance, on index flexibility, on things like that. Not as much recent work in some ways on relevancy ranking. Again, it's open source. It's what the people who are using it, what their needs are. But from the point of view of a complete kind of roadmap, you would say that for certain enterprises, there are gaps. So how do you deal with these weaknesses? Well, the first and foremost one is the Lucene Solr community, which is a great one, which is all of you and the people who couldn't make it to this conference. It's a responsive community. It's an easy place to get answers. There's a huge amount of information available there. It's easy to contribute new work. It's easy to work with committers to get new work that's of value, that's done well, committed. So that's the first place that people would go to address any of those weaknesses. There have been and will be consultants available, not necessarily formally associated with a big company like a FAST or an Endeca, but independent consultants, because that's the nature of the open source. Commercialization is another one, of course. So if we look at other open source projects, how have those gaps been addressed? In some ways, a role was played by companies that formed around the technologies to provide those gaps, to fill those gaps, rather. So Red Hat is a good example. MySQL is an example. we like to think Lucid Imagination is trying to fill some of those gaps in that way as well. Not exclusively, but as another tool for answering some of those weaknesses. And then, of course, internal resources. In most cases, open source will imply some greater level of internal work than you might for a commercial product. Not necessarily. I mean, depending on the success of commercialization and these others, you can approach the level at which the open source, in effect, is just like a commercial product, except that there's sort of the open source development community and the commercial backers behind it. Strengths of the top commercial competitors. This is a short slide. The next slide is the weaknesses, which is a longer slide. So there are strengths, of course, of the commercial competitors. The biggest one is that these people have been cranking out features for the market, for the commercial market, for 10 years. The good news from a Lucene Solr point of view is that not all these features are really needed any more than all the features in the latest version of Microsoft Word are needed. So they're full-featured for sure. They're bloated in some ways. Some of those organizations have focused nicely on particular domains, particular applications, and DEC is a very nice e-commerce solution. MarcLogic works very well with XML content. Recommind does very well in the legal domain. So specialization, not every product can do everything. There's obviously a way that some products may be a better fit for certain applications. Some competitors have really focused on a simplicity angle. One comes to mind in particular that offers an appliance, and that's got its own strengths. It's got its corresponding weaknesses. It's an appliance. It's not meant to be customizable. It's meant to plug in and do something well really quickly. The weaknesses of the competitors, those are pretty significant. The first one, and it's a hard business reality. I mean, search has been a fortune. It's probably not going too far to say that a lot of those companies have been gouging users for years and years, charging for difficult technology and charging what the market would bear, millions of dollars for installations for a lot of those search products, especially at large scale, at the hundreds of millions, at the billions of documents, many millions, tens of millions of dollars. Platform and portability limitations, not all of them are written in Java, most of them aren't. There are other kinds of limitations. One very well-known search technology, recently acquired by one very large company, seems to be more Windows-focused these days rather than Linux and Unix-focused, and that can be a problem if you're running your search system, as most enterprise search systems are run, on a Linux or Unix platform. Limited transparency, by definition, if you're commercial, it's not open source. So for some of these products, it's a bigger problem than others. People don't know what's going on. Why did the documents rank this way? How can I improve it beyond the ways that you've given me to improve it? Limited flexibility. Of course, again, there's only so much you can do with the customization tools that a commercial product gives you. Limited customization, I'm really talking about the two things together there. Sometimes limited scalability. Again, we find that other than Fast, which has got some issues now in that list, and Google, which doesn't really offer the full version of Google, and Lucene and Solr, only one of the three, all of those products have some scalability problems, in fact. Some of them very significant, some of them not so. A lot of them have added distributed indexing and parallel searching after the fact, and that kind of works, but it's not the same as doing it from the beginning, and very few of them have actually re-architected. Technical debt, just because of the nature of being a commercial company, you've got to maintain versions for a very long time. It limits your innovation. You've got quarterly numbers to meet. There are some issues there. And of course, you're dependent on a company staying in business. So what's the competitive landscape today? How have those commercial companies dealt with those weaknesses and with the challenges that we've seen in Solr? They've felt the pressure, for sure, in the last 5 years. You talk to the salespeople at those companies, they run into Lucene Solr now in places where they didn't run into it before, in the Fortune 500, in governments, in small companies, people that didn't know about Lucene Solr before. The word is getting out, the revolution is happening. We were looking to see if there were any guns being held here, but there aren't, actually. But this guy is drinking from a bottle. I just noticed for the first time. Anyway. Some of the competitors have responded by basically giving up, right? I mean, they really can't compete against Lucene and Solr, so they've reinvented themselves, which is a reasonable business strategy. They're no longer large generic search providers. They can't get those dollars anymore for those search deals, so they're now BI companies, or they're working in a particular market, or they produce applications of which search is a component. Some have been acquired. The commercial market is being consolidated. But the need for good search in more and more places, for it to work really well, especially to be tuned for better than mediocre search, which is still what you get in most websites in most places, that remains. So the future, again, I think at the point we're at right now, the basics have been sort of commoditized. There's really, by default at least, not a good reason to start by thinking you need something other than Lucene or Solr. You might. No one technology is going to be good for every application, but I think increasingly that's the default choice because it says good or better and it's free. Again, the commercial companies have the weaknesses that I just talked about. Producing best practice search is still hard. The need for innovation will still be there for Lucene and Solr to remain a dominant technology. The other competitors aren't going away anytime. They've got large installed bases. They have lots of money to throw at things, but it's kind of hard to justify those prices. And it's really hard when you get into the discussion with Lucene and Solr. I mean, you talk to a mid-range search company. Do you really want to buy that technology being dependent on that proprietary search technology 5 years from now? Where's that company going to be 5 years from now? So in the end, I think Lucene Solr, because of where it's at in terms of capabilities and price, if it continues to innovate, if it continues to have the strong community and a community that grows, is likely to be the dominant technology for a very long time. Last slide is just some list of resources. We'll post this presentation, so I'm not going to go through them here. We've got some very nice resources on Lucene and Solr now. A good book on Lucene, a good book on Solr. Lucid Imagination has case studies and lots of other information for people who are interested. Am I out of time or do I have 1 minute? Okay, we'll stop there. Thank you. I just want to say a couple more things. I got a text message about a slide that I went through too quickly. So Lucene and Solr, most of you will know this, but for those who don't, it may be worth pointing out a little bit more clearly the difference between the two. So Lucene was the Java library that Doug wrote in the late 90s that provides the core indexing and search capabilities. To use it, you've got to write a Java program or use one of the ports of Lucene to another language. When Solr came about, the main goal for Solr was to make it easier to build Lucene applications. So it added things that people who were building Lucene applications found they were doing over and over again. Tools for keeping track of the index, a schema, capabilities for caching, for replicating indexes across machines, and so on. It also added faceting, which was a functional change, not just an infrastructure change. And it put Lucene over HTTP, so you're no longer limited to writing in a particular language. You can invoke it from any language. Today, most people, for those reasons, usually start with Solr. There may be some cases where Lucene is a logical starting point. The other point I wanted to mention was that we've got a Stump the Chump challenge at the end of today, and we're still looking for more questions. Mark Miller, are you around somewhere? If you've got some questions for our chump that you would like him to try to answer, please see Mark so he can collect the questions. Yeah, Mark's not the chump. He wanted you to know that. So, okay.